All right, so you'll be glad to know that today we were going to do what we've been doing for the past 2 days, but instead I decided to give you something easier. You're welcome. Merry Christmas. Okay, so today students will be able to write using technology quadratic functions that provide reasonable fit to data in the estimated solution for real-world problems. So it's with quadratics again. We're going to write quadratic equations, but we're going to do it with our calculators. So a quadratic function is anything like that x squared. Quadratic parent function, y equals x squared. A parabola is the shape of a quadratic function. X-intercepts, that's where the parabola crosses through the x-axis. Also called solutions, roots, zeros, and factors. They're all the same thing, okay? Vertex is the very lowest point or the very highest point on a parabola. Axis of symmetry is that line that splits it in half. The maximum's like a mountain. It has a max, okay, the very highest point. Minimum, like a valley or a hole. It has a very minimum. Quadratic formula, this is your quadratic formula. If the discriminant is greater than 0, you have 2 real solutions. If it's less than 0, you have no real solutions. And equal to 0, it's 1 real solution. Standard form, y equals ax squared plus bx plus c. Vertex form, y equals a, x minus h squared plus k, where h and k are the vertex. And completing the square we don't need to go over right now. Oh, okay, awesome. So, here's what we're going to do. I'm going to go back to this page. We are going to find the equation of this table. So I know it sounds crazy, but we can get the quadratic formula, or the quadratic equation, from this. All right? I know it looks scary, it looks hard, but trust me, it won't be. So, take out your calculator. All right, so we're going to go to stat, okay? And then you hit edit, okay? Stat, edit. All right, now we're going to put all the x coordinates, which is always this side, into L1. So we hit -2, enter. Do that. Then you hit -1, enter. Do this with me. 0, enter. 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. Okay? Oops, I don't know if I got 5. Oh, yeah, I did. Okay. Then in L2, go over to L2. We're going to type in all of our y coordinates. Y is always on this side. So -23, enter. -7, enter. 1, enter. 9, enter. 17, enter. 25, enter. And 33, enter. Double check and be sure yours match with the chart, okay? So now that we've got those in, second, quit. You got to get out of there, okay? We're gone. We're out of it. Go back into stat. We want to calculate, so go over to calc, the quadratic regression, okay? Notice there's a linear regression. That means you can do this for linear equations too. So we want quadratic regression. So we want number 5. Then hit enter. Okay, so this one didn't work. You want to know why? I just realized. Look at these numbers. -23, -15, -7, 1, 9, 17, 25, 33. They're constantly going up, right? Okay, that makes this linear. So go back to stat. Oh, sorry, let's quit this. Go back to stat, over to calc, and choose the linear regression. Choose number 4. Well, that one didn't work either. But we did the steps right. I promise. We did the steps right. Okay, so let's look at this one. Okay, this one, if you look at it, it's going from a high number, it goes down, and then it starts going back up, right? So that tells us that it's quadratic. So let's go in and clear everything in stat. So stat, edit, and we're going to clear them. Right, to clear them, go up to L2, hit clear, and enter, and it should clear the whole thing. Go over to L1, up to L1, hit clear, enter, and it should clear the whole thing. All right, so let's type in these numbers here, okay? So -2, enter. -1, enter. 0, enter. 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. Okay, go over to L2. Here we go. So at -2, we had 14. 14, enter. At -1, we had 9. 9, enter. At 0, we had 6. 6, enter. At 1, we had 5. 5, enter. At 2, we had 6. 6, enter. At 3, we had 9. 9, enter. 4, we had 14. Enter. And at 5, we had 21. Enter. So be sure you have all of those in there. Pause this if you don't have them all in yet. Pause. Okay, so now we quit. Get out of there. Let's clear this because it's making me upset. Go back to stat, over to calc, and remember this one's a quadratic, so we want the quadratic. So we choose number 5. 5, enter. There you go. So this tells you y equals ax squared plus bx plus c. A is 1, so it's 1x squared. B is -2, so it's minus 2x, and c is 6. So let me get this out so I can write it on there for you. Okay, so what this is saying is y equals a is 1, so it's 1x squared, and remember you don't have to write the 1. -2 is b, so it's minus 2x, and then 6 is c, so it's plus 6. This is your equation. All right? See, that's what I was trying to do the whole time. Okay, so now let's go back. I'm going to show you something else. We have this paper right here. You don't have this paper. I have this paper. Okay, and on this paper, it's doing one with years. I want to show you that one. Okay, so anytime you're dealing with years, okay, you're always going to start off that first year needs to be 0 because that's where you're starting. Okay, 80 is 10 years after 1970, right? So this is 10. 1990 is 20 years after 70, so that's 20. 2000 is 30 after, okay? 2005 is 35 years later. And 2007 is 37 years later, okay? You don't actually put the years. That's not going to work. Because years and actual numbers are a little bit different, okay? So you have to put it in like this. So let's do that. We're going to take out our calculators. We're going to type this in. Okay, so let's go to stat, edit. Oh boy. Well, I'm just going to do this. Stat, edit. And we need to clear it, right? So go up to L2, hit clear. Enter. Go over to L1, hit clear. Enter. Okay? So, we have 0 as our x, because it's the year, and then 497,000 is our y. 497,000. Enter. Next part. 10 is our x, and this is our y. Next one. 20 is our x, and this is our y. Next one. 30 is our x. And this is our y. Whoops. The next part. 35 is our x. 4, 7, 0, 6, 8, 8. That's our y. And the last one. 37 is our x. And that's our y. Let's see what we're even calculating here. Okay? The question would say, find the question would say, I'm trying to find the question here. Well, it's giving you a list of years and what the population is. So the question may ask you something like, what is the population in such and such year? Okay, so you're finding the equation so you can find what the answer is in such and such year. Okay, so from here, we quit. Go back into stat, over to calc, and we want quadratic, so pick 5, hit enter. Okay, so this one's kind of weird and funky. Oh, let me go back to this. This one's kind of weird and funky, but you would write it the same way. So it's y equals ax squared, ax squared plus bx plus c. Okay, so instead of putting a, we'll put 302.8. So y equals 302.8 x squared. Instead of b, we put negative 11479.6x. And instead of c, we put plus 501,226.8. Okay, that's a really funky equation, but this would be your equation here. Okay, so that's how you find linear or quadratic regression, or how you would write quadratic equations giving a list of points. Okay, so I want you to finish the 2 problems you have to work today, and then we will be working on Alex the rest of the class period.